Hello. So I want to start by thanking the panel for joining me here today, and I wanted to say happy 10th anniversary to Augmented World Expo. So in the 10 years that I've been coming to this conference, there's been quite a few evolutions in the AR space. But this year I think we're at a unique inflection point. And the reason I say that is because the technologies and the tools that are being developed by the companies that are represented on this panel and others, they're providing us the capability for our augmentations to inhabit the real world in a much more realistic and compelling and intimately connected way. And so my company is really excited about that. My team has been helping our customers to use the AR cloud for their business goals by creating rapid prototypes and custom applications. And so far, we've been really pleased with the results. Now, before I get into the introduction of the panel and the questions, I wanted to do a really quick level set and overview of what is the AR cloud. So can I get the slides back up?
Yeah, just don't look at the
Thank you.
Sorry?
All right, so what is the AR cloud? The AR cloud is a persistent 3D digital copy of the real world, continuously updated in real time, in which a persistent augmented reality experiences reside. Thank you to the OpenAR Cloud for this succinct definition. So what goes into making the AR Cloud? I wanted to talk about like 4 key components, not necessarily a comprehensive number of components, but the 4 key things that go into the AR Cloud and what types of things those unlock for a developer and when they're building AR applications for the AR Cloud. And the first key one is the precise device pose. So where am I located and where am I looking? And let me get a little closer so I can see which is coming up next. All right. And so that tells us like where a user's device, be that their cell phone or their head-worn device, it tells us where is that precisely in space and where are they looking. And why is that important? First off, it allows us to do content discovery. We can make a spatially based query and say, what's around me? This is a dystopian version from Hyperreality, if you've seen that film. Also, if we know where you are, we can get you somewhere else, and we can provide overlays correctly positioned to get you to where you need to go. And also, it unlocks the ability to do a multiplayer context. So, for instance, this is an example from one of our panelists, YOUAR, where they have a collaborative building experience. So if I know where everyone is, then each person sees from their perspective what content is in the space. The next thing I want to talk about is an up-to-date digital twin. And what is that? That's an accurate enough 3D model of the real world. And I say accurate enough because it depends on the context that your application resides in. So are you augmenting skyscrapers or are you augmenting someone's kitchen table? That matters to what level of detail you need for a model. And what does that provide for us? So one key thing is occlusion. So this is an app that my company, Patch Reality, created called Babble Rabbit. And you'll notice that as the bunny runs around the room, it can go behind the furniture. And it really enhances the realism that you get by having that. And then another thing that you get is real-world physics. And incidentally, the Babble Rabbit was built on 6D.ai's technology. And this is another example from 6D where you'll see that the balls are bouncing off the table. They can go into the bowl. They can even bounce off the table leg. So really key for enhancing that realism of an application. Next thing I want to talk about is a persistent content storage. So this tells us what are the characteristics of the content that's being served up in the space and where is it. And why is that important? Well, if I want to go down to the park and build a Minecraft creation with my friends and come back to the park and see it there, or let other people see it for that matter, we're going to need to have that spatially indexed CMS. Also, it provides the ability to do content overlays. This is an example from another one of the panelists about Sturfee, where they're showing information about what's in a building by just tapping on a window in the distance and telling you how far away that building is, what's the elevation. You can imagine all kinds of interesting data that can be painted on the world, to quote Charlie Fink. And then lastly, it unlocks the ability to do offline authoring, which will be very important. So this is an example for another one of our panelists from Resonai, where a technician on their laptop is spatially locating a trouble ticket attached to a specific electrical panel in a building. And then the technician can go later and see an AR view to guide them to where that problem exists. And the last important key ingredient I wanted to talk about, and this is by no means an exhaustive list, but and that's semantic understanding. And that's the AR cloud will tell us what are the objects in the general vicinity of the user, what are their characteristics, and you know, how is the space that they're in made up. And what does that help us do? That's going to help us do more intelligent interactions. So if I want to create an avatar that can sit in the chair, interact with a keyboard, this is an example from Celerio, then I'm going to need to know, my application's going to need to know where are the chairs in the room, where one might sit, is there a laptop that my avatar can interact with, et cetera. Also will allow for much more intelligent overlays. If we can surface to a driver the hazardous road conditions ahead, other cars, maybe even pedestrians, then hopefully we can provide a much more safe and efficient driving experience, for instance. And there's many, many more. I mean, this rabbit hole is pretty deep, I'm sure, in terms of semantical understanding of the world and what our applications will be able to do. So those are the four of the key ingredients. And then I want to talk really briefly about who the players are in the space. So of course we have the bigger players. They're already starting to get really involved in building this out. And of course we have standards organizations which are starting to codify what an open and interoperable AR cloud will look like. And then of course there are many, many startups in the space, and like always, some of the most interesting and ambitious work is being done there, and that's why we've assembled 4 leading panelists from 4 of the leading startups in the space to talk to us today. So without further ado, I'd like to introduce our panelists. So first up, we have Matt Miesnieks, and Matt is the CEO and co-founder of 60.ai, and Matt's company has an AR platform that builds a 3D mesh of the physical world using a smartphone camera, enabling virtual objects to understand and interact with the environment. So Matt is a renowned AR industry thought leader, and 60 is his 3rd AR startup. He also helped found Super Ventures and built AR system prototypes at Samsung, and he's had a long career in mobile software infrastructure before jumping into AR infrastructure back in 2009. So that's Matt. And next up we have Galia Schwarz. She's the VP of Business Development at Resonai. And Vera is Resonai's computer vision-based platform for commercial spaces. So Vera makes it possible to develop apps that solve everyday challenges by using an intelligent understanding of a building's entire 3D space. Galia previously led business development and sales at several AI startups in the domain of computer vision. She has a PhD in strategy, and she researches R&D innovation in disruptive industries at the Technion and New York University. Next up, we have Ray DiCarlo. He's the CEO and co-founder of YOUAR. Under his guidance, YOUAR developed one of the first persistent AR full-stack systems and the first computer vision-based solution to allow disparate computer vision-enabled devices to exist in a common space. He also co-founded internationally acclaimed animation studio Bent Image Lab and the Open AR Cloud to enable millions to discover, create, and share AR experiences. He's the co-author of 5 pending AR-related patents. And last but certainly not least, we have Harini Sridharan, and she's the co-founder and CTO at Sturfee. Sturfee has a unique city-scale outdoor AR technology for visual positioning of 3D meshing that combines street-level pictures with satellite imagery. Harini's educational background includes a PhD in machine intelligence and computer vision for high-resolution satellite image analysis, and she pursued a postdoctoral program at the prestigious Oak Ridge National Laboratory. So can you please give it up for our panelists for being here today, because it's quite an impressive bunch. So I wanted to open up the questions first by going back to one of the key questions, the most important, and of course one of the most challenging aspects of the AR cloud, and that's the localization piece and finding out the precise device pose. So I wanted each of you to talk a little bit about how you are building the SLAM map or other data used for positioning and how it's used in your system, and then also what do you see as the advantages of your approach? So why don't we just go down the line, I'd say.
Okay. Yeah. So
it's a multi-part question. So
yes. Yeah, I could talk for an hour just on that. So yeah, that problem of localization is still a very hard and unsolved science problem. It's really only been solved in specific cases. So I think all of us have got different approaches to solving different parts of that problem. One of the things we try and do with our approach is do as much as possible on the device. The company's a spin out of a research lab at Oxford University. We've got some state-of-the-art technology that means that although we're associated with the AR cloud, we do pretty much no processing in the cloud. Like everything happens on the device. The reason for that is we think that the user experience needs to be as close to real time as you can. So anything that has a back and forth to the cloud degrades that. But also that privacy really matters, and that to solve, to do a localization involves like taking some image data from your phone, like what your phone's looking at, and then trying to match that against a SLAM map or a map of the world that the system is in the system. And so if that system is being run in the cloud, then some of that image data needs to go up to the cloud. And that's something that we've really didn't want to do. We didn't think that that was a smart idea for phones to be, unbeknownst to most people, sending some sort of images up to, either to a carrier or to the platform company. And even with their best intentions, you don't really know what could happen with that data. So it's, as far as we're aware, it's something that's completely unique to the way 6D is approaching this problem, and it's something that we're just continuing to invest in.
Very cool. Thanks.
So our focus is on large 3D spaces or commercial spaces, and we scan these in advance and reconstruct them in the cloud in 3D. And the result of this reconstruction is basically a labeled mesh. So it's the mesh of the building where we recognize the different objects in the building, and we give tools for developers to add more labels. And then in real time, we collect data from the user's mobile device. So from the camera, we collect video streams and align them to that mesh to define the precise position and location of the person in the building. And our algorithmic approach assumes exactly that we have on one side the mesh of the building and then video streams in real time.
Yeah, our approach is similar to Matt's in one way in that we do everything on device. But one of the things is that we write on native CV, so we can take our CV, which basically sits on top of other CVs, so we can work with any device, so you can make a map on an iPhone and see it on a HoloLens. And we have a global system that relates these maps to each other. So we do send data up to the cloud for the whole system, but we gather such little amounts of data that it isn't recognizable as an image. We don't move any images. We don't move anything that could be uncompressed and actually know where it is. So that's kind of our approach to it.
So ours is a little bit different. So what we provide is geospatial intelligence for cameras. So as Patrick introduced, my background is in geospatial science. So is half of the team from Sturfee. So for us, the key goal is anything at city scale. So the approach we took is deriving data from stack of satellite imagery to get an understanding about the area and leverage that knowledge, infuse it with the data collected from the device level or the ground level, and provide localization and 3D geometry for the device that way. So typical SLAM approaches uses data collected from the ground or the street level. So we do it a little bit differently, where we merge a top-down approach where we have data from satellite imagery, which is this perspective, and merge data with this perspective. So the advantage of this approach is scale. Like, we can power a city like San Francisco, whose area is roughly 120 square kilometer, in about half a day's time without having to ever step on the field. Disadvantage of this approach is I'm never allowed to travel anywhere. I just sit at the same office, yet power AR in areas like Tokyo or Shanghai or Seoul, but I never get to travel to these places. So, yep.
All right, thanks. Yeah, it's interesting. It was really interesting to me in assembling the panel to see the diverse ways in which you're kind of coming at this problem. And so I think, you know, there's probably some developers or many developers in the audience, and one of the things that I always want to know is, like, how do you engage with a platform? Like, as a developer today or in the near future, what types of use cases are your customers asking for? What types of use cases are kind of your sweet spot? And how does one use your technology? What type of devices is it? It's a, you know, kind of a broad question, but we can take it in any order if somebody wants to jump in.
I'll start. So we're building a platform that's, you know, something more like Amazon Web Services than an application. So we aren't really trying to solve the use cases ourselves, and so there's I guess a sort of balance that we need to try and strike as a business between, look, we're just going to build some tools and throw them out there and hope someone figures something out, and that approach never really works. And the other approach is that we're going to try and build a full stack, and we're going to build everything from the core technology through to the application and the user experience and some, you know, hit app on top of that, and that probably won't work either. So our approach, you know, in terms of use cases has been to really look for customers that understand the problem that AR can solve for them, and then we can very quickly, you know, them and us assess that whether our technology is going to solve their problem, and then we pretty much get in lockstep and solve it together. And that's led to, you know, very large customers that we're working with. They usually have in-house engineering teams. They're, you know, 6-7-figure projects, and they touch on things like, you know, real estate, you know, architecture and engineering, you know, big authoring tools and authoring platforms, you know, OEMs and some of their hardware solutions. And, you know, we're sort of working with them, and then as we get, you know, together, get confidence in these use cases and sort of figure them out and get them out into the market and see how they work, then we can start to, you know, not standardize, but kind of, you know, get what we've learnt there and make it easier for other people to kind of replicate similar types of applications.
Cool, thanks.
So our SDK will be released to developers at the beginning of next year. And what Vera really offers is tools to create apps or web experiences through the entire life cycle of a building. So from design to construction, and then maintenance and operation, and end user experiences. And these are experiences that utilize a precise understanding of the entire 3D structure of the space. So, and that's one thing that's very important about Vera. So apps that are created on Vera are defined through semantic rules. So for example, you can define an experience that requires a table, a chair, a floor, and a wall. And anywhere where we see a table, a chair, a floor, and a wall, that experience will adapt to that environment. We don't need to know in advance what their shape is or what is the setting in the environment. The app can adapt to any environment that complies with these semantic rules. So what really Vera offers is scale, because you can create immersive experiences that can scale themselves to multiple locations. And we've been experimenting with different use cases and talking to companies across this entire life cycle to understand these use cases and to provide also the tools to developers to support them later on. Because one thing that was very clear to us from day one, I mean, we come from a background of gaming and entertainment. We wanted to create experiences that solve problems that are today. So first of all, we're focused on mobile AR at this point. And any experience that is created on Vera can be consumed on any phone that has ARKit or AR Core. And the type of experiences that we've been working on with customers are indoor navigation, smart control of IoT devices, AR tutorials for appliances. We've seen different things around maintenance and construction on aligning BIM models to the actual scan of the building in order to view in AR then the pipes and the wirings of the building. And of course, end user experiences, which are more around gaming or, again, AR tutorials. This has been our focus so far, but eventually, once we release the SDK, anyone can create with it anything. We don't want to control the creation process of content that is created on Vera. The experiences that we are creating today are, first of all, to demonstrate the use of what can be done with Vera, but also to know what tools we need to support in it for developers and building administrators.
When we started, we really were trying to inspire people, and my background is in production and animation, and what we want to do is we want to create tools for developers to easily make interesting augmented reality experiences without suffering through all of the really hard stuff like figuring out how to localize or figuring out how to get multiple players at the same time. And what we ended up building was something that's closer to an operating system. We call it an operating environment, which allows you to run multiple applications at the same time. It allows applications that were built by different developers, if the permissions are there, to actually talk to each other. So I can have an application that has a ball throwing and throw it into an application that someone else built if they gave me permission and knock something down in it. So we're really about how to quickly and easily make very dynamic interactions and experiences for people. That SDK will be out next year. Currently, though, we're allowing the computer vision side of it, which is a AR cloud solution. You can start building your AR cloud with it now if you're a developer. Matter of fact, if you go to youar.io/CV, you can sign up. We're going to take on some early partners in doing that. But a couple of things that it offers is its global positioning. It gives you adaptive solutions, meaning that the clouds can adapt to lighting conditions, or if you're moving objects, it will recreate a cloud that will understand that. We're also giving you access to the actual data in the cloud, which people aren't generally doing. You can't get it from like Google or anybody else building that stuff. And will allow you to host your cloud data yourself if you want to. I have that one video that just shows that adaptive. It's very short. Do we have time to show it?
Yeah, probably. I guess so. Let's see.
So this is a quick little demo we did the other day, was simulating like morning light.
Oh, the clicker.
Simulates morning light and midday and evening light. And we're basically visualizing the cloud with edge detection, which is just telling you where the clouds are. And so one of the things different of our system is we have what we call multi-mapping, which you can add maps, and we kind of believe that a map of the whole world is going to be too hard to handle, but if you can move from place to place to place and always stay connected to the map, that's kind of our approach.
Okay.
Oh, this is the second part of it. We're moving objects around. So it'll keep rebuilding the map as long as it has enough information, but at the end here, he throws on a bunch of stuff and it creates a new map because it couldn't handle the extra information. So that's kind of our approach.
So we provide access to our technology using a Unity SDK. Sorry?
Sorry, you can go back to the video.
Oh.
To the video feed. Sorry. Go ahead.
Yeah, sure. So at Sturfee, we provide access to our technology using a Unity SDK. So the SDK will allow you to access our visual positioning service. So any developer who, and it's currently on a closed beta program, so any developer here who wants to work with us with an interesting use case, please come and talk to us, and we are more than happy to work with. But apart from that, we work largely with the enterprise customers, and one of the most exciting use case for them is our content management platform. So we provide this easy ability to game designers, marketers, or salespeople, or even developers, to have a platform where they will be able to drop any 3D content on a map, which is very similar to either Google Maps or Mapbox. It's a regular 2D map, where they can place a content in a given geolocation, and then when another user goes to the ground and opens their phone in the AR mode, then our SDK or our technology will directly allow them to localize properly and show that 3D content that was dropped in a map in the right location. So a great example of this use case is, for example, DoorDash delivery, right? So if I'm ordering food from DoorDash and I want them to kind of deliver it in the right door, this building, one side of this building has about 5 doors, so I can go and drop a pin at the exact door where I want it delivered, and the person, delivery person standing outside, he or she can open their phone and localize themselves using our technology very precisely in the real world, and can know where this dropped pin location is in the AR mode. So for us, all our coordinate system is in the geospatial coordinate system. So some of the examples that Patrick pointed out, multiplayer, content persistency, all those come very naturally along with our services. So yeah, that's what we provide.
Very cool. Well, thank you everyone for that. That's awesome. So I wanted to talk a little bit about, so what are some of the thornier technical issues or even other barriers that are beyond the technical that you see to wide adoption of AR cloud technologies by developers in the enterprise or by consumers? And what do you think, what are you doing to block and tackle those? Maybe we should mix it up a little and maybe start with Galia.
Oh, so of course there's the hardware, and I think a lot of the resources are going today to the hardware. Because we're not a hardware company, I don't have a lot to say about that. I think on the software side, we're seeing there's not really today a very viable business model for AR content creation, because on one side we have experiences that are powered by AR SDKs like AR Core and AR Kit, and are basically interacting with surfaces. And apart from a few examples, most of these are not very engaging because surfaces are not very meaningful to people. And on the other side of the spectrum, you have very immersive and interesting AR experiences that are tailored to specific locations. So you basically see them in a museum, and they can't scale themselves to other settings. And even if you move the object in the same setting, they probably would not work. So there's not a real motivation from the developer side to create. If you have to choose between not engaging and not scalable, there's not a viable business model for AR content creation. And this is exactly what we're trying to address with Vera. I think also on the platforms and tools side, you need the right platforms for AR content creation, and you need tools to test how experiences will look from your desktop before you actually implement them in the building or anywhere else. And so this is, again, something we're trying to solve in the ecosystem that we're providing around our Vera SDK. So it's tools for exactly testing, evaluating how experiences will behave.
Interesting. How about you, Harini? Do you have?
Sure. So one of the constant or thornier issue that I have always been asked with is instant localization, right? Everybody wants to open a phone. Immediately they want the magical experience to happen. Nobody wants to hold the phone more than 1 second. They don't want to move around with it to map the area, right? Everything has to be instant. So that user experience seems to be a big barrier, right? And when it comes to AR Cloud especially, anytime you bring AR Cloud, there's a latency in the network aspect of it. So those two are the issues that needs to be addressed when you're developing a cloud-based solution. In that aspect, again, instant recognition, right? Even in areas where there's not been a previous mapping, like SLAM kind of a mapping, people want almost an instant experience. So in that aspect at Sturfee, since we're using satellite imagery as prior, wherever we have had satellite imagery, any moment a user opens the phone, from the first frame, we can start giving that kind of AR experience because we can localize them almost instantly. And then coming to the issue of network latency, I think Matt's company is doing great in doing a lot of the processing on the phone. So we also kind of do a very similar approach of kind of converting images into very lightweight signatures so that transferring them to the cloud becomes very light. And I mean, I think per frame, our signature size is only about a kilobyte. That way, that network latency part is kind of eliminated from this whole experience.
Yeah, it's interesting that you mentioned the localization problem. When we were making BabbleRabbit, I can't tell you how many iterations of that experience we went through because we didn't want to do the standard thing where you just show, wave your phone like this. We wanted it to be more of a game and trying to come up, we had you chasing a butterfly at first and that didn't quite work, and now we got you collecting a seed. But there's definitely a lot of human factors that needs to go into that.
And especially if you're on outdoors, people don't want to keep their phone open a lot of times. I think last summer we had a customer in Dubai. Dubai in summer gets very hot. You don't want them to be opening their phone and waving all the way just to get the localization and then to the experience to start. They are not very happy about that. So.
Yeah. Did anyone do you guys have anything to add in terms of the barriers that you see to the wider adoption? Yeah.
Well, I think they're right in that there isn't an AR cloud yet, so it makes it difficult for certain
that's
things.
one big barrier, yeah.
And I also think that that people have underestimated sort of at least the smartphone interaction with 3D objects in AR. I know when we spend a lot of time thinking about the person using it is going to do and how they're going to feel. And I remember we were talking about it, and the guy said, "Oh, we can just do this out on paper." And I'm like, "No, you can't. It's a visceral thing. You actually have to build it. You have to try it. You have to walk around because it doesn't work like you think it would work. It's none of the kind of interfaces that we've done before."
Yeah, that's really true. Did you say you had something to add?
Yeah, there's just so many.
Yes.
That's the blockers are just so obvious that anyone who's ever tried to build an AR app or use an AR app is just immediately, you see problems. So the challenge, I think, while the technologists are kind of working on just grinding away at solving these problems to get it to be instant and just 0 clicks and just works type experience, which is hard technically to do. I think that something the industry has really struggled with is there's technologists and then there's excited product and creative people with good ideas, and there's not too many people with foot in both camps. And a lot of the problem with the way to approach these blockers isn't so much trying to solve all of them, because then you try and boil the ocean. It's to try and figure out which ones of these can be solved, technically, now, today, in the current time frame, but that also match up with a use case that's going to make sense to somebody, that there's also a market for that's big enough to sustain, your company. And, that sort of straddling all three camps, is so rare in this industry. And that seems to be, I think, if we can find people, either technologists who figure out design or marketers who figure out technology or whatever, that seems to be where I think the opportunity is to sort of discover and uncover some good ideas.
And I would add to that. I would say that I actually think that the technology for each thing is kind of as close to being here as you're going to get, but the scaling of it and making it practical for just an average user. I always say, could my mom use this?
Yeah.
That's interesting. Okay, well, I guess I'm going a little out of order, but this is okay. I think what I wanted to jump to is the different scales at which these user experiences happen, either city scale or room scale or building scale, indoor, outdoor. I mean, it seems to me, that a lot of the decisions being made about what scale, for instance, Sturfee is going to do outdoor, are being driven by expediency, because that you don't want to boil the ocean, like Matt said. How much of it is that, and how much of it is just the fact that there are different contexts for different tasks, and so naturally we're going to see that. Or do you see that eventually most of your solutions will kind of blend towards an all-in-one solution that covers all the bases?
Yeah, it'll definitely be a solution that covers all the bases. That's, you know, even in 6D we see a very clear, you know, there's no risk, it's just work really to get to that.
Yeah.
Where I think, again, sort of similar to the last answer, the question, the difficult question today is like, what's the right use case for the scale you're working at? And you know, you see something like HoloLens, and that's great for like a factory, but you're not going to use it outdoors. And you know, outdoor games like Pokemon and stuff work great outside, but they're not that good to play in your living room. So again, figuring out that design problem, and then if you are going to do something that you want to use outdoors and large scale, you then got to accept that, well, you needs to work on this type of device, not a headset device for the next few years. So yeah, I think the scale question isn't really one about the technical work to build that out, or you know, things being islands. It'll definitely all end up, you know, things will just work at any scale, anywhere. But what's the right thing to build right now? You know, one anecdote, I guess, from you know, the time at Superventures is we'd often have people come and talk to us about ideas for HoloLens, but they were thinking that this is going to be like a mass consumer app, and we're like, well, no, you know, unless people are going to spend $5,000 for your app, it's not going to take off. And then at the same time, they'd come up with some, you know, other people would come up with, say, a great enterprise use case that there's great ROI around it, and it's going to save some company money, and they'd think it's an iPad app, and you're like, well, you know, someone has to use like hazardous equipment and work this hands-free. You should be building it for a headset. So those sort of design, you know, trade-offs and decisions and understanding, you know, it's not just you don't just have to have a good idea for a use case. You've got to have all those pieces together to work today.
Yeah, Galia, did you?
I don't have much to add. I think in the long run, I agree with everything Matt said. I think in the short run, we're still seeing solutions tailored around specific use cases, and each one of them optimized around some basic assumptions for that specific use case. And some technologies will probably be easier to transition into a wide array of use cases, like a good SLAM should cover multiple scenarios. Other technologies will be harder to implement in a occlusion in a one-size-fits-all use
Right.
case.
So you need like a variable voxel size that can scale up or down for the situation, that kind of thing? Interesting.
I agree. I don't think we have a solution for what we call our near clouds and our far clouds. So I'm not worried about that on a technical level. I agree with Matt. It's just the amount of work to get all that stuff finished. There are a couple of things that are interesting that happen differently in AR, is like if you fly around a shark, which I've done a lot of, or fly around a dragon, which I've done a lot of, you find that it takes a really long time to get from a mile away to you. And it's a whole different experience. So sure, you can make something really big, but I think you're back to that user experience again and what's appropriate in the space that you're in. I mean, as far as if you're wayfaring or things like that, I mean, those can be done in both places, just in different ways.
And it seems like from Sturfee's standpoint, you know, you're using satellite imagery. Obviously, you don't have satellite imagery of indoor spaces, but I suppose eventually you may start using other acquisition technologies.
That's the dream, right? You can use floor plans of the buildings still the same way you use, I mean, satellite imagery is the blueprint of the world, so you can use the actual blueprint of the building to kind of try and do the same thing indoors. However, having said that, again, this is a point I think all of us agree with, right? The experience, right? Yeah. It's not too wrong to have different technologies tailored for different use cases, right? Absolutely. Why should we try to go towards a one-glove-fits-all? I mean, from developer standpoint, maybe, but a lot of times the experiences is also not to make it work seamlessly. The use case, if there's one use case that somebody comes up with that should work great both indoors and outdoors, sure, come talk to me. I would want to talk to you a lot more.
One of the things that we did do with our system, because we have a system of anchors, right, is we thought ahead of time thinking that the way that you create your maps is going to change. The technology is going to get better.
Yeah.
So basically, we have the ability to completely change a map and not lose the position of an experience that's been placed there even a year earlier. And also, if I'm in a courtyard and I see a building a mile away that has a cloud on it, but there's no way I can see it, right? Like I can't track to it, but we still know where that other, if it's a big enough object, we'll see it in the right place because we have a system that keeps track of all that.
Right. Yeah, somebody at the OpenAI Cloud discussion yesterday was saying it's really hard to track the ocean. You know, like obviously, like, we're not going to have a SLAM for open ocean tracking.
You have satellite imagery for that.
There you go.
Sure,
You
but
have satellite
predict
imagery
it,
for
right?
that, yep.
okay, maybe I'm wrong. They were wrong. Interesting. I think we have time for one more question for me, and then I think we'll open it up to the audience to ask questions. And the one I mentioned the OpenAI Cloud, and there was a talk just before us about the OpenAI Cloud effort. Now, what in the mission of the OpenAI Cloud Association is to drive the development of open and interoperable spatial computing technology, data, and standards to connect the physical and digital worlds for the benefit of all. That's a mouthful. So what, if anything, is your relationship to that effort? And do you eventually imagine that there will be standardized air cloud protocols and data models that you will support in your solution? At what levels do you think that's going to happen? I'm just curious to hear what you think on that.
Well, at YOUAR, we started something called the OpenAI Cloud Foundation because we knew that we weren't big enough to build an AR cloud by ourselves, and we look at AR as the next internet. We call it the Internet of Places, and we always have. And so our hope was that the ability to be on that internet, the AR internet, was free for everyone like the internet is now, and it wasn't like back in the day when you had to be on AOL to get on an internet. So we started that, and then we met Jan Eric, who was trying to do something similar with a whole different technology, and so we decided to put that together. So we're really big proponents of open standards. We're willing to adapt to any standard that the bigger group believes is the right one to use, but we would like to see an open standard.
I can go.
Sure.
So same thing, generic. We are part of the same OpenAR.org as well. So we actively follow the standards, especially on the common framework for geoposes, and we already follow a lot of standards with the OGC, as half of our background is in geospatial science. So yeah, in the future too, if there are agreed upon standards by consortiums, we are happy to participate and conform to them.
I think you mentioned something about not like you don't want to be like the IoT, right? What are you saying?
No, that's a different discussion.
Oh, okay.
No, what we were talking before is that how the internet has forgot the word in English, but concentrated around specific standards. And
Coalesced, I believe. Coalesced, is that? Yeah.
yeah, and then you have like another example in IoT where that didn't happen and where it's a big obstacle to the adoption of IoT technologies. And we're looking at the efforts done and monitoring it closely. Like many other players in the industry, we hope to become that standard that others will follow. But we think that this exploration phase, this whole field is such an initial stage, and this exploration field stage and looking at different approaches is very important and beneficial to us all. And I think it's obvious to most people that, or at least we hope that the industry will converge around uniform standards and protocols.
Yeah, that's a really good point. What do they call it? Let 1,000 flowers bloom. Try and experiment. Yeah, I like that.
Yeah.
I'll take the contrarian view on this.
Okay, good.
I kind of mostly believe what I'm about to say. I don't completely believe it, but I kind of think we're kidding ourselves if we think the open AR cloud is gonna really work. I think for a couple of reasons. The first is that we talked about localization technology and that ability to get your coordinates and the SLAM systems. Right now, those systems are, super proprietary. They're moving, at a very rapid pace, largely funded by, the either VC money or the big platforms themselves. And these SLAM systems are ultimately what the entire user experience of these, headsets or phones depend on. And so it's going to be a long time before, Apple and Google and Facebook and us and others sort of start letting, each other have at each other's, SLAM data formats. So anything below kind of geo coordinates is going to be, heavily proprietary, and we'll all have our own coordinate systems, and there'll be sort of a challenge to sort of map content from something that you built on an ARKit map to a 6D map to a HoloLens map. And at that point, I think there might be some sort of interop bridges, being built. But second thing is, if the mirror world gets built, and the mirror world is that platform for all these types of applications, the companies that won and lost in mobile and in the mobile ecosystems, and they learnt the value of having an app store and their own hardware and what that means, they see that this same the same sort of stakes are at play for how the mirror world is going to shake out. So I don't expect a bunch of plucky amateurs to kind of luckily come together and build something that's better than what these big investments are going to be driven by, especially when they've got the power of controlling the full stack and controlling the whole user experience, and they can just iterate on the whole thing extremely fast. And the scale of the phone ecosystem is big enough that they don't need to interoperate. They can have it entirely, all the iOS users is big enough to fund whatever they need. So yeah, I'm sort of, I don't hope that that's how it's going to happen. I don't entirely believe that's how it's going to happen, but if I had to bet, I wouldn't be sort of, I definitely don't think it's a matter of, oh, open standards are the answer and we should all get behind them. I kind of think that's the less likely way that this world's going to play out. Sorry.
Well, on that note, I'm sure you all have some burning questions. So do we have a microphone in the audience that we can
So quick rules for the question. A question ends with a question mark. Yes, and we have to finish by 5:59. So raise your hand, and just one question per person, please, and then we'll get the next one. Yeah.
Hey everybody, Jason Fox with OpenAR Cloud.
Matt, we have a question.
I certainly appreciate Matt's viewpoint on it, but if we were able to come together and develop a data interchange that your proprietary data could be converted into and then shared with this AR Cloud, or the mirror world, whatever you'd like to call it, is that something that you could get behind? Do you feel?
Yeah, so I would point back to, like, I worked for a company called OpenWave, who invented WAP and invented the smartphone browser, back in the early 2000s, and so I saw this whole like emergence of the mobile ecosystems. And back then there was, there was Symbian, there was Java, there was Brew, but there was also this mobile web that was going to be the open platform that meant everything was great, and we didn't have these like carrier portals and islands of ecosystems. And what ended up happening was the devices, like building a native app on the device with the native APIs that that Apple and Google and others, Nokia at the time, like tried to build, resulted in a user experience that was just like infinitesimally better. It was like a couple of milliseconds more responsive. It was like one less click in order to make a purchase, and that tiny difference, and all those big companies slowed down on the way that they implemented their APIs for the open web as well to give themselves an advantage. And so that just led to this slight not level playing field that meant that native apps were, sold more. So if you built a native app, your sales would go up. And so I think that you know, I mean, not, like I said, I don't think this is good news, but I sort of think it's kind of probably how the world's going to play out, is that when you get to headsets and these user experiences are even more intimate than our phones in our pocket, and we're more sensitive to interruption and to delays and responsiveness, that, you know, that the experiences that are in the closed ecosystems are probably going to end up better than the open, you know, versions of those. And so while I think, you know, an open interchange format is going to be useful and beneficial, I still think the value is going to be in the native closed, you know, products.
I've got a question surrounding, hey there, I've got a question surrounding security and kind of like hackers in general. What degree are you already doing like pen testing and like graffiti artists trying to like destroy your key points so that you can't relocalize? Like, is that something that you're already testing against or theorizing? Just curious.
Theorizing, you know, where, you know, I mean, there's just multiple facets to an answer to that question, but apart from like all the obvious stuff like, you know, just good infrastructure, hygiene and passwords and all that sort of stuff, at the science level, we're thinking a lot and again, relying a lot on the Oxford, you know, team that we've got there to, you know, my co-founder Victor, who runs the Oxford Activision Lab, he like never wants me to say something's impossible, you know, but he always qualifies as like how hard it is to reverse engineer something. And, you know, for us right now to go from our SLAM data format sort of back to a image, you know, human readable kind of image of your home that you may have scanned, would mean like 2 unsolvable or currently unsolvable problems being solved, you know, and somehow no one really knows if they're solvable or what the results would be. So that's kind of the approach we're taking at that sort of fundamental level of can someone actually do something malicious with the data that we do store. And then, of course, we're just trying to, you know, within the resources we've got as a startup, just implement good practices in how we, you know, what we don't capture, we only capture the minimum, and then how we manage it once it's on our infrastructure. I don't know. Anyone else?
One last question. After that, we go to the pool, try VR apparently in the pool. So we got that last question.
That will be in the pool.
Yeah. No, you know everything? Ah, yes.
Oh.
It's a light-hearted end question.
Yeah.
I presume everyone's seen the trailer for Minecraft Earth, and it's going to be the first sort of mainstream AR application that uses persistent AR content. I'm just wondering what everyone's thoughts are of that.
Yeah.
I didn't understand the question.
Oh, Minecraft Earth. He's saying, what are your thoughts on the fact that Minecraft Earth is going to be one of probably one of the more popular allow persistent content, yeah. What are your thoughts on the fact that there's going to be persistent content with Minecraft Earth?
I still don't understand the question, so maybe someone else
I'll
can
dive in.
answer.
I mean, I've answered the last two.
I think I've mentioned geospatial coordinates for quite some time now.
Yeah.
So persistent content is possible. I mean, one of the solutions that we provide, again, we provide everything in the geospatial coordinate system. So if we localize one user, he or she is in the same coordinate system as another user. So the multiplayer aspect is inbuilt in our system the same way any object, 3D object that we place is again in the geospatial coordinate system. So the content you place today is going to be staying at the same latitude, longitude, and altitude in the real world. So persistency, again, is an inbuilt option, but as of today, we do offer the solution only for outdoors, any kind of outdoor spaces. Take cities like San Francisco or a park in San Francisco. So yeah, persistence is possible.
I think the biggest thing, like for us, we've had persistence for a long time. So I put a dragon in Cuba at the Resistance Museum, I don't know, 2.5 years ago. It's still there. Because we have an offsite on-site solution, we can add things there anytime that we want to. But now you're talking about scale, and it's always been about network effect and scale. So if they come out with persistence that's got a network effect to it, it's going to be a big boon to AR in general, because you really need to get people on the system. The more people you get on the system, the more the system will actually be used by additional people?
I reckon it's a great trailer. I don't think the app will live up to the promise that they, promoted in the trailer. From memory, I think they imply things like occlusion, of moving stuff and solid stuff, which, as far as I know, Microsoft hasn't got anything outside the labs that is doing that. And I think that I'm very interested to see what the terms and conditions are for how that spatial data is used. Currently, their spatial anchors are kind of, if I build an app and it saves spatial anchors, then those anchors are only for my app. Your app can't use them and your app can't use them. So if Minecraft is really successful, it might build all these sort of spatial anchors that are good for Minecraft, but if there's some other Xbox game that Microsoft wants to launch, they've got to start again and build a whole new map of the world for that app. So unless they kind of do something, and they've been very commercially and legally cautious about that sort of stuff. So I'm kind of, I think it's a good trailer.
Yeah. And I'm told we're out of time, but I wanted to warmly thank everyone for coming today.
Thank you.
Thank you.